Yeah.
Yeah, go ahead.
Yep. 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 So this will be the presentation for the office hour of our MagNet challenge final evaluation. So in this presentation, we're gonna quickly go through the some rules and the instructions for the final evaluation. And firstly, here's the timeline that we want to show to every participant about the final evaluation. So firstly, we have released all of our testing data on November 10th, where you can find all of the new training data and the testing data from the following link in the five additional materials that we use for this final evaluation. And then you use this data to train, tune, and refine your model or algorithm using the training data. And finally, we will predict the core losses for all of the data points that we put in the testing data for the five materials. And for each material in the final submission, please format all of the results into a CSV file with a single column of the core loss values. And in order for us to make a correct and a smooth evaluation of the results accuracy, please make sure the index of these values is consistent with the testing data so that we can really match the prediction results with the measurement results. And the final submission will be due on December 31st, and where we firstly need all of the five CSV files that we just mentioned for each of the materials containing the testing data, testing results. And then a 5-page attribute detail format document will be due as a PDF, where you just document all of the details of the algorithm or the model that you constructed and also the results you get, and to briefly explain the key concepts. And also, we hope to do a code evaluation for the winning teams. And to do this, please follow the instructions in the later of this presentation to make a fully executable model as a zip file. And in the end, submit all of these required materials to the email account of this MagNet challenge. And in the end, in the January and March of next year, we're gonna do the model performance evaluation, the code review, and also we're gonna discuss with the judge committee to select the final winner. So here's the brief overview of the final evaluation dataset that we created for the five new materials. And in order to make the competition more fair, we have kept all of the name of the material to be anonymous, and we here just label it as A, B, C, D, E. So in the folder you download, you can find two subfolders. One is the training dataset, the other one is the testing dataset. In the training dataset, there will be five CSV files, including the magnetic field waveform sequence, which will be formatted into n times 1024, as what we have for the first round of the materials. And here is the number of data points in each dataset. And also similarly, the H field is also a waveform sequence. The frequency, which is now a column vector, n by 1 column vector in the hertz, and also the temperature n by 1 in degrees Celsius, and finally the volumetric loss is also a single column vector in watts per cubic meter. And in the testing set, on the other hand, there will only be 3 CSV files, because here we hope to do the test. We no longer provide the H field and the volumetric loss. These will be the thing that you need to generate with your own model. And
You don't
here,
need to generate an edge, by the way. You
oh
don't need
yeah,
to edge. No.
yeah. The union will only require the volumetric loss, and this will be predicted based on the 3 CSV file provided in the testing dataset, the B field, the frequency, and temperature. And similarly here, n is also refers to the number of the data points. Here we give a brief overview of the number of data points for each material, and in this table. So here we have listed the number of data in the training dataset and testing dataset for all of the 5 materials A, B, C, D, E. And here in the bracket, we also show the number of data points for each type of waveform shapes, including the first one is the sinusoidal waves, the second one is the triangular waveform, the third one is the trapezoidal waveform. And here you can get a get a quick idea of how many data points are contained and what shape of the waveform are they that contained in each of the data sets. So here we want to emphasize that you can see that the distribution is not really balanced. This is because we have doing some intentionally splitting and the selection of the training data and testing data in some specific ways so that we can test the model performance in different aspects. And this will be different from material to material. So in the end, when you do the training and do the data engineering, you will see that the data distribution may be unbalanced, and this is normal and of course should be considered in when you're developing or refining your own model. And in the end, after the challenge is finished, we're gonna release all of the complete data sets for everyone to do a final check. Secondly, as for the result submission, so here is some quick instructions to ensure that we can have a smooth and also correct evaluation of your results. So firstly, in the end, please submit a zip file which contains the folder. We have shared this as a template on our website, where you're gonna rename the name of the folder with the name of your team. For example, the name of your university. And then there will be two subfolders in this folder. One is called model, where you're gonna put all of your code and related files into it. The second one is called results, where you put all of the output files, which means the 5 CSV files containing the volumetric logs into this results subfolder. So for this, in the end, we're gonna do a code evaluation. So here are some more detailed instructions on how to put your code into it. So here we have created some templates for both Python-based code and also MATLAB-based code. You can find these two files in the model subfolders. So here we have created a function called colors, and where you're gonna wrap your model or algorithm into it, so that we can have a uniform input-output structure of these colors, and we can simply execute it when we do the code review. So this colors function will have 3 inputs: the B, the F, and the T, which stand for the frequency waveforms, the frequency and temperature. So the shape and the units are the same as what we just said for the data set. So in this function colors, you're gonna integrate all your own model or algorithm into it, and in the end, the output will be your model should generate the colors as a single column vector, and in the unit of the watts per cubic meter, and then this result will be written into a CSV file, and this is supposed to be the one that you submit for your final submission. And as we just mentioned here, want to emphasize again that please make sure the index in the output file is consistent with that of the input, so that the predicted result is really matched with the measurement results in terms of the order and the index, so that we can check for the accuracy. And also to guarantee a proper code evaluation, please also make sure that in the end, when we run this code of the colors, the generated file is the same as the one that you submitted, so that we can make sure that all the results are correct. And as for more details, in any case, when you have any functions called from other files, please try to use the relative path address whenever possible to indicate the file locations, so that we can easily load and compile all of the results, all of the code. And also for Python users specifically, if you are using any function called from other modules or packages, please create a requirement text file in this folder to indicate the package name and the version, so that we can run your code correctly. And also please make sure all of these packages are all open source and accessible. And similarly for the MATLAB users, maybe you want to use some specific toolboxes. So also please try to create this text file to indicate the name and the versions of this toolbox, and make sure they are accessible to everyone, and we can download it so that we can run our code correctly. Here in this screenshot, we have shown this is a quick overview of this code template that we created for both Python-based code and MATLAB code. So essentially, there will be a function called colors with the 3 inputs, and here you're gonna wrap your own model or algorithm into here. And here, as an example, we just created a random function generator, but you will replace this with your own model, and in the end, the result of this model will be written into a CSV file. And similarly, this is done in the MATLAB. So in the end, please make sure that the code are fully executable, and so that we can do a smooth and correct code evaluation of the code that you submit. And also maybe there are some teams using other languages, other English languages other than Python or MATLAB. Please also try to follow the same instructions in the to pack and integrate your code in a similar way so that it's easily executable.
But we do prefer Python or MATLAB because that reduces our effort.
Right, exactly. And in the end, as we just mentioned, we also expecting every team to submit a report PDF into the folder. And please make sure that one thing that you need to contain in your report is the total number of the parameters indicating your model size, because we have mentioned that the model size and it will be one of the metrics that we considered in our final evaluation. And this number will be further double checked during our code review process. And more specifically in this challenge, we have considered all of the values that related to the magnetic material characteristics as the parameter of the model, such as, for example, in neural network models, you have all of the learnable parameters are considered as the parameters, or in analytic model, any of the fitting coefficients will be considered. And some of the other parameters that may be related to, for example, the indexing will not be considered. So please try to report the correct number of the model parameters that contained in your own model. And in the end, in your final report, please include a table showing all of the number of parameters in your model for each of the materials, because we know that for different materials, you may have slightly different model structure or number of parameters. So here we show the example that you have the column. You have a table to show the number of parameters for each of the materials, the model that you use for each of the materials. And in the end, please pass all of the results, the code, the 5 CSV files, and also a PDF into this folder and package it as a zip file for submission.
Yeah, so for these parameters, I guess there will be a lot of questions. So our guideline is just try your best. And we will, for the final winners, we will do our work to figure out what's the best way of evaluating the size of the model, because I think this highly depends on whether you're going with analytical or data-driven model and the model structure. So yeah, we'll try our best to do a fair job, but I guess for model size, there's no just golden rule saying which model is much bigger than the other model. So we'll do a more of a qualitative evaluation of the size of the model in the end.
Right. Exactly. Yeah, so that's all the overview of this final evaluation rules. So let me know if you have any questions.
May I have a question?
Yep.
Yeah, my question is regarding the point that you mentioned about the number of parameters. So, for example, if we have a set of parameters in our model, and with that set of parameters in the model, we obtain an accuracy, let's say 2%, 3%, but with a quite low number of parameters. But what if we just add a few to the number of the parameters, and we have more accurate model? So it's not clear for me, at least, that how you judge our model. You said that 30% for the accuracy, 30% for the number of parameters. What's not a little bit clear for me.
Yeah, that's right. So I guess this is actually the most challenging piece of running this challenge, is that we are asking for accuracy and model size together. And you can always make your model very accurate by increasing the model size. But on the other hand, your model looks more and more like a lookup table, less than a model. So what we are asking for as a result is we trust your judgment. Like, you think which one is better from your logic. And that's why we're asking for the 5-page documents. Explain to us what's the thinking logic behind the way you design your model. We don't want it to just by trial and error, like we tested model, it happened to work great. Those are not the kind of model we're looking for, but we're more looking forward to learning, what do you think about the best way of solving this problem? And what do you think if there's a standard model that everybody should use to evaluate magnetic material? Why do you think your model is the best? Yeah, and that's what we are looking for. So that's why we have a judging committee. We don't intend to simply select the winner by saying this model has slightly better performance than the other model, but we are more looking forward to learning about what you are thinking. And ultimately, the final goal of this competition is hopefully as a community, we can find a way that everybody agree this is a very good way of evaluating material and everyone should do it in a similar way. So I guess that's sort of the reasoning behind it. Don't put too much effort in just selecting A or B. I would encourage you to think about, well, if someone has to compare A and B, what are the logics behind it? And we look forward to see it in your 5-page report or during the code review process. What the code review will look like is maybe we'll ask you guys to prepare a 10 minutes presentation, a brief 10 minutes presentation, and tell us what you learned and what do you think will be the ultimate best way of solving this problem. And regarding the performance and parameter trade-off, give us what do you think could be the best, or you can probably report. Ultimately, we'll only accept one model because we have to report the result in some way. But in your report, you can say that I tested 5 models and these are the performances, and that we'll factor that in the final selection process. Although if we end up generating a table ranking the team's performance, there will be just one number, and that's your best performance that you selected as reporting. Does that make sense?
Yeah, clear. So it means that the 5-page report is important as well.
That's right. Yes, actually very important. Yes. Or we look forward to learning from you guys. What's your thinking, and put your thinkings there.
Okay, clear. Thank you.
Yep. I noticed there are multiple other friends joined after we started. Maybe we can do a quick self-introduction because we run it as office hour. We didn't anticipate all the teams will come because some teams may just get started. They don't have any questions. But we hope to make this a opportunity for us to know each other and say hi. And after the competition, we're friends and we're collaborators. Maybe we can go around the table a little bit. I saw Emmanuel. You want to say hi to everyone?
Hi.
Maybe a quick self-introduction.
Yes, I'm Manuel, a PhD student at Arizona State University. I'm competing in the competition.
Great. Emmanuel, do you have any question? Do you have any question, Emmanuel?
Yeah, I think the question that Reza asked was also relevant to us because, yes, we know, for example, we can get our errors because we can measure them. Then now we are understanding the importance of a good reporting. Yeah.
Right. Yes. Yeah. So generally, you may have multiple methods, or we hope to learn from you. Oh, what do you think makes sense? And hopefully, and that's what we find as very challenging running this competition. But I think if our goal is ultimately advancing the knowledge, things can get simpler. And it will be more of there will be debates, there will be discussions in the judging process. So the winning team probably won't be the one who report the best result because it's very likely someone just by trial and error find a really good model. But what our intent is that we hope to select the winner as the one who both deliver good results and understand the reason why their model performs well. I see Ashir. Do you want to say hi?
Yes, hello. I am a PhD student from Spain, from the Mondragon University. I don't know if you can hear me correctly. Yeah, we decided, we saw the MagNet challenge and we were already working with the MagNet database, which you guys put online, which has been like something really helping me with the PhD. So it's like a very good initiation. And yeah, I think that in my regard, I believe that, I mean, of course, there will be subjectivity, as you said. You have to decide what's the best. But I think everything is clear in my end. So
Yeah. We'll try to make it clear as possible. That's why we request all the teams to open source their code so everyone can do cross-checking. everyone can go and then try to understand what other teams are doing. So I hope winning is definitely a goal, but advancing knowledge, and hopefully if you didn't win this, but this competition turns into a chapter of your PhD thesis, that's also a great outcome. So we should think in the long run instead of just thinking about winning by numbers. Any other question, Asher?
No, not really. I think everything is quite clear for my side. So
okay, great. So I saw Jing Wang.
Hi, can you hear me all right?
Yes.
Hi, everyone. This is Jing Wang from University of Bristol. I'm currently an assistant professor here, working on power electronics and magnetics. So I'm supervising our student team for this competition. And thank you for Princeton colleagues to share extra details on this. But I'm afraid I have to go in 5 minutes. I got another meeting, but
Sure.
this has been very useful.
Great. Do you have any question? Anything that is you feel like we can make it clear or?
Potentially one, if not mentioned before. So we see there are a few data sets, for example, for material D that has a very small training set. Is that done on purpose? I guess
Yes.
that's the question. Okay.
It is, yes. So we select the material which we think will be a good material for testing the model's capability of being trained by tiny small amount of data.
Makes sense. Thank you.
So that's why we sort of make it comprehensive. Also answer the previous question is we have 5 materials. So you could have one model which perform well on one material, but doesn't work well for other materials. So in the end, we are sort of we'll try to do a comprehensive evaluation of the model because we intentionally design the material so that some of the material we tested for how is the model being able to train by tiny small amount of data, and then generalize to a huge amount of testing data. The other materials we intentionally take out. There's a hole in a range, like maybe you just don't have data at a particular temperature, waveform, or frequency, and we'll see if your model will be able to somehow fill up the hole. So one thing I want to mention is that maybe you will find that the previous 10 materials could be useful because maybe some of this material is similar to the previous 10 material, and the data from the previous 10 material will help you to fill up a gap. So these are the kind of, we intentionally set it up so that we can look at the model from different angle. And there's no absolute winner in the end.
Right. Thank you. That makes sense to me.
Yep. Great. Ray Zhang. Ray, I guess you joined late, and now we're doing a roundtable introduction because we know this is we want to run this as more like an office hour instead of a presentation. So hopefully you can make friends. We saw ASU, University of Bristol, and Mongona University in Spain, right? And Reza is from TU Delft. So Ray, where are you from, and do you have any question? You're muted. Anyway, I guess okay. I guess he's not closely following what we were saying. So yeah, that's almost all we have. Any other thing we want to discuss before we finish this meeting? And well, in the coming 3 weeks, the same time, one of us, either me or Haran or Shukai, will be here, and we'll be happy to answer any questions you may have.
yeah, I have a quick question. With the last, I don't remember how it was, but with the preliminary test, for example, I added a document trying to explain the model and everything. I remember that for the first submission, there was like a review or some respond. I guess it won't be the case with the preliminary test, right?
No, there's no, because preliminary test is just getting yourself familiar with the rule. And honestly,
okay. Just to generate the numbers and understand how the classification is, right? I guess.
Yes. Just try to understand. Right now, we know 25 teams are serious. Like we have 40 teams registered and 25 teams submitted number. That's the purpose. We want to get a feeling of how many teams are doing serious competition. And second is get yourself familiar with the rule. How do you generate data? And how are you going to report the error? Yeah, so we're not going to provide feedback. There's no way we can provide feedback. It's a self-reported.
Yeah. Okay. Okay. Thank you.
Yeah. Okay, great. I guess that's all we have for this week. If there's no questions, we'll finish this meeting and we'll see everyone next week if you have any question. All right. Thanks, everyone.
Thank you.
Thank you.
Thank you.
Bye.
Thank you. Goodbye.